So when our polynomial is not factored, like this one is not, we can't just pick off zeros the way we did when everything was factored. So this is where our synthetic division is going to come into play. But first, before we start thinking about synthetic division, what we're going to do is use something called the rational zero theorem. And you don't really need to know that theorem so much as know how to use it. So here's what it allows us to do. We are going to look at the last term, and we're going to look at the coefficient that's in front of our leading term. And we're going to list all the factors of 12 and all the factors of 2. So factors of 12, and we want to think both negative and positive. So as we list them, let's just think they're both negative and positive factors. All right, so 12, let's see, 1 goes into 12, 2 goes into 12, 3 goes into 12, 4 goes into 12, 6 goes into 12, and 12 goes into 12. So those are all the factors of 12. Now for 2, the only ones are positive and negative 1 and 2. All right, now what we're going to do is make a list of possible zeros. It doesn't matter that it doesn't mean that they are zeros, but it's a possible list. So our possible zeros what we do is we take each of these numbers over here and we put them over the top of these numbers. So starting with the 1, I could have 1 over 1, and I'm going to put a positive and negative because they could be positive or negative. So I could have positive and negative 1 over 1. Well, 1 over 1 is just 1. But I could also have 1 over 2. So I could have positive and negative 1 over 2 is a half. All right, so that's 1. That's this 1 over both of these. Let's go to 2. I could have 2 over 1. Well, 2 over 1 is 2. I could have 2 over 2. Well, 2 over 2 is 1, so I've already listed 1. All right, so let's go to 3 and put 3 over both of these. 3 over 1, well, that's 3. And then 3 over 2. Well, 3 over 2, positive and negative, 3 over 2. All right, well, that's 3 over both of these. Let's go to 4 over both of these. So 4 over 1. Well, 4 over 1 is 4. 4 over 2. Well, 4 over 2 is really 2, so we don't need to list that again. All right, that's 4 over both of these. Let's go 6 over both of these. 6 over 1 is 6. 6 over 2 really reduces to 3, which we already have. Now lastly, let's go to 12. 12 over both of these. 12 over 1 is 12. And we can have both positive and negative. And then 12 over 2 really reduces to 6, and we already have 6. So these are all the possible zeros. So what we're going to do now is we're going to start with one of them, and it doesn't matter which one. I suggest you start with the ones that are nice round numbers, but we're going to do synthetic division with the possible zeros. So I'm going to start with a positive 1. So I'm just beginning at the beginning of the list. We could start at the end of the list if we wanted to. And I'm going to divide 1 into my polynomial using synthetic division. So let's see, we've got 2. This coefficient's really a 1. Negative 25. And 12. So let's do our synthetic division. And remember, that's multiply, add, multiply, add, multiply, add. So first we bring down the 2, and we multiply, add. So 1 times 2 is 2. Add the column, that's 3. Multiply, add. 1 times 3 is 3. Add the column, it's negative 22. Multiply, add. 1 times negative 22 is negative 22. And add the column, that's negative 10. Okay, now immediately, Notice that what we got right here is not a 0. If it's a 0, that means that what we've divided by is one of our zeros. Since it's not, we've not found a 0 yet, so I'm going to go to -1. I've tried +1. I'm going to go to -1. So, change back to my blue again. I'm going to do synthetic division again. This time, I'm going to do it with -1 out front. Now, let's notice this is a tedious process, and it will be. So, doing synthetic division again with -1 out front. Bring down our 2. -1 times 2 is -2. Add, and it's -1. Now let's multiply and add. -1 times -1 is +1. Add the column, -24. Okay, now multiply and add. -1 times -24 is +24. Add the column, that's 36. Again, that is not 0 right there. So we have not found a 0 yet. We go to the next one in line. So instead of a half, though, we can do a half. We can do multiplying by a half, or rather division by a half. But let's go to 2. So I'm going to go to a +2, just to avoid fractions. And let's divide 2 into it. Again, bring down your 2. So 2 times 2 is 4. Add the column, that's 5. 2 times 5 is 10. Add the column, that's -15. 2 times -15 is -30. Add the column, that's -18. Again, this is not 0, so we still have not found a 0. All right, well, let's go to the next one in line, -2. All right, so I'm going to divide -2, and I'm just going to do it over here. Now, as we can see, this can be a very tedious process, but we can find our zeros this way. And on a test, it's going to be one of the first ones you try, but I wanted you to see, first of all, that it can be quite tedious. All right, so let's bring that 2 down and do synthetic division. Multiply, add, multiply, add, multiply, add. -2 times 2 is -4. Add the column, that's -3. -2 times -3 is 6. Add the column, that's -19. -2 times -19 is -38. Add the column, well, we can already see it's not going to be 0. This is still not one of our zeros. So I'm going to go back to the 1/2 that I kind of skipped over just because it was a fraction. And I'm going to divide 1/2 into it. Just so we can see that sometimes dividing the fraction is the one we want. And it might not be this one, it might be -1/2, we'll see soon. All right, realize though, as you do your multiplication and your addition with the fraction, you can use your calculator if you don't want to go through all the fraction operations. So 1/2 times 2 is actually +1. Add the column, we get 2. 1/2 times 2 is again +1, add the column, we get -24. 1/2 times -24 is -12. And that is 0. This is our first 0. I'm going to use a different color. That's a 0. So that one worked. Okay, now that that one has worked, I've got 1 0. With my synthetic division, I started with an x to the 3rd power as my function. So this answer down here at the bottom of the synthetic division is 1 less in its exponents. So let's write out, this is 2x squared, 1 less. Going down in exponents, this will be 2x, and this is 24. Now, since this is quadratic, this should factor for us. Let's notice that 2 is the greatest common factor, first of all, for all of these. So let's take that 2 out. And 2 into 24 will be 12. And let's now factor the stuff that is in these parentheses. So if I factor x squared plus x minus 12, factors of negative 12 that add to 3 will be x, or add to 1 rather, will be x plus 4 and x minus 3. Now that we've got that factored, we can pull their zeros out. We have a 0 of negative 4. We have a 0 of positive 3. And then let's not forget, as we list our zeros, that our other 0 is 1/2. Now, we may also be asked not just to list the zeros, but to list the factors. We have 2 of them there. We can list the 1/2 as x minus 1/2. All right, but typically what ends up, what the factor really is 2x minus 1, because if you think about setting that to 0, you're going to end up getting x minus 1/2. And so notice when I kind of convert that, that 2 ends up in front of the x, and then the 1 sort of stays there. So if we have a denominator, it can kind of end up being right over here, and this factor really lead to the same 0. So if you do have problems with MyLab or with MyOpenMath not accepting this factor, try this one. Just take your denominator, stick it in front of x, and they're really equivalent to one another. Now I want to do one more, but I'll do it as a separate video.